Fieldwork. Every geographer's favourite word. So, what is it? Obviously, it's getting out in the field. It's doing work out in the field. Funny that. But truly enough, it is the best form of learning. Being outside, observing, analysing, assessing, evaluating, taking in all of this information that is available to us is, yeah, it's the best way of learning in geography. Every lesson should be outside where possible. Unfortunately, not every lesson we can be outside. Not every lesson can we travel to mountain bike trails or travel to China to look at the influence of uh, globalization. But in saying that, we can still, when we have the opportunity, take these fieldwork opportunities to really make the most of it. So today I'm going to step you through the basics of fieldwork, what we need to do, what we need to look for, what we need to use, and how we can best act and make the most of our time when we're out in the field. So we're looking at fieldwork, obviously in relation to maintaining and designing sustainable mountain bike trails. So we can see here some mountain bike trails. We will be taking this opportunity to look at some of the tools that we can use to assess and evaluate one particular example of a set of mountain bike trails and whether they can be considered sustainable. If not, make some recommendations known so that they can be brought up to scratch in terms of those 11 principles of mountain bike trail design brought to us by the IMBA. So let's have a look through. The first thing that we need to have is an idea of what we need to do when we're out in the field. A lot of the time when we're out in the field, it's very easy to become overwhelmed, to become maybe distracted by those things that are not inside the four walls of the classroom. So making sure you've got a checklist. What am I looking for? What do I need to do while I'm out here? And I'd suggest that you write that down. Have that on a piece of paper. So it might be, and a real example is that maybe people, once they finish school, they're out in the field collecting information for a particular project, also need to really relate what they're doing while out in the field back to their project or their task. So making that clear and specific, a checklist that you can check off, hence the name checklist, is really a great thing to do because it keeps you on task and makes sure that you're looking for what you need to and that you're meeting those objectives or those things that you really need to be doing. So that's the first thing you need to do, and I'd suggest that you do that before you go out in the field. So write yourself a checklist. Okay, we're dealing with mountain bike trails, and mountain bike trails, I guess, go hand in hand with topography, with the shape of the land. They're designed, or should be designed, in a way that works with the land, not against it. So using relevant topographic maps. So a topographic map shows topography. It shows the shape of the land through contour lines. Knowing what a contour line is, knowing how this shows the shape of the land is vitally important. Being able to read, interpret, and make judgments based upon topographic maps is imperative. So here we've got a topographic map of Port Macquarie. This map has a scale of 1:25,000. If you don't know what that means, it's important that you do some bit of research before you get out in the field. Because when we look at things such as distance, how long mountain bike trails are, obviously we can use things like Google Earth, Google Maps, GPS, etc. But going back to basic topographic maps, being able to work out distance, height, local relief, and these types of things becomes vitally important, particularly when you're designing or when you're looking at maintaining mountain bike trails. So I'd suggest that you get a topographic map, you know how to use it, and you take it along with you when out in the field. A clinometer. One of these funny things here on the right. You hold it like a gun. Yes, you might think that that's funny, but we use it in mountain bike trail design to measure slope. Now, in the first module, I talked a lot about slope, gradient, percentage, degrees, etc. Now, slope is vitally important. Some of our rules, not exceeding the half rule, making sure that you have an average gradient of 10% or less, are some of these things that we have to make sure that our trails are meeting. So a clinometer is a tool that we use when out in the field to measure slope. There's also some really cool apps available on your iPhone or your iPad that you can use to also measure slope. We'll have a look at how to use a clinometer more specifically in class, but having a clinometer, being able to use it to be able to identify slope is vitally important and is one tool that people working on mountain bike trails highly recommend that you don't leave home without if you intend on designing or maintaining a mountain bike trail. Next one, a field sketch. So yes, we might be able to take photographs, and photographs are really important. They provide lots of information. But annotated field sketches, done obviously while out in the field, are vital as well. Uh, they show lots of information. You might be able to relate things such as, in this case, obviously cities, transport networks, the shape or topography of the landscape. Now, in our case, we might annotate field sketch of some mountain bike trails. We might do a field sketch like this, or we might do a little bit different. But again, being able to show information that relates to obviously the topography, and in this case, mountain bike trails, is vitally important. And we'll be doing a field sketch while out in the field. The next, GPS. So here on the right, we have a GPS that might be used for things such as bushwalking. A GPS creates a file type. That file type is .gpx, and we can upload that file into Google Earth, Google Earth Pro, or Google Maps. So for example, while out in the field, we might walk the track, and one person might hold the GPS and create a route of that track. Now, when we get back into the classroom, we can share and distribute that file, upload it into Google Earth, and record lots of information and observe lots of data. Things such as distance in kilometers or meters, average gradient. We can look at a cross section of the trail. We can note things such as local relief, the highest altitude while on the trail. And also it shows us on a map where exactly this trail is. So GPS, it may look like that, but you also have a phone. Some phones, we can use specific applications to be able to record tracks and trails. So have a look at your phone, do a little bit of research, and see if there's a particular app that you might be able to use to record information while out in the field. The next is a camera. Obviously, we've got a 5D Canon there, probably a bit of, overkill. Your iPhone, your basic point and shoot camera is all we really need when out in the field. Its purpose is not to provide an artistic view of the landscape, but just to record geographic information. So if you're noting particular areas of the trail that require significant work because of erosion, take a photo of it. Now, and speaking of taking a photo of it, if your camera or your phone doesn't have what we call geotagging, you might want to note down on a map, whether that's a field map, a topographic map, or a map of the trails, where you took that particular photo. Because when we come back to class, we can upload those photos onto our Google Map. Now, iPhones and some point and shoot cameras and SLRs have what's called a geotagging capability. That means it records the latitude and the longitude of that specific area where you took that photo. Now, when we upload that onto a map, it'll automatically place your photos where you took them. And for us as geographers, people who like maps, use maps to show information, in this case, areas that on a mountain biking trail that might need some work, that's really useful and is something that I would suggest that you have a look at and see whether your phone, whether your camera, or one that we might be able to use, has geotagging. Last piece of technology that we're going to use, and that's becoming more and more so used by people working in trail design or people working in aerial surveying or surveying in general, or working for local governments, for example, is drone technology. Obviously just a camera, but a little more than that. And it's about this software that we can also use to create maps. Drones are obviously amazing for creating aerial images, and when we're looking at geography, your uh, top-down view, your bird's eye view, or more specifically your NADAR image, NADIR, they are really useful because we can use online technology to stitch these together to create our own maps. And these maps can be really high quality, and they can also show features of the landscape. We're hoping to be able to use some of this while out in the field, and drone technology, such as our Phantom 4 Pro that we have at school, is becoming more and more widely used. I have a friend who works for a local council, and they have to do an audit of how much rubbish is at the tip every so often. It used to take surveyors up to 3 days' work, whereas now, with drone technology and some of the online software, they can calculate in metric tons how much waste is in that particular facility in less than 3 hours. So drone technology, mapping, photography, and other software is becoming highly used, and we get to use it for looking at areas of mountain bike trails that need some work. So by using those particular strategies to gather information, we should be able to have fieldwork opportunities that are really, I guess, worthwhile getting out of the class, and we can bring information back to the classroom to make judgments, to make evaluations based upon some criteria. Thank you.